To finish our lesson on measures of position, let's talk about deciles. A decile divides the data set into 10 groups. To find the deciles, we're just going to use what we did with percentiles and look at percentiles by tens. So the 10th percentile would be considered the first decile. The 80th would be the 8th decile. Deciles are not very common, so we're not going to spend a lot of time on this. For quartiles, just like quarters split things into 4, quartiles will split our data into 4 groups. Quartiles are used extensively, and we're going to see this again in the next section in 3.4. For quartiles, quartile 1 is the same as the 25th percentile. Quartile 2 is the same as the 50th percentile, which is also the same as our median. Quartile 3 is the same as our 75th percentile, and quartile 4 would be our maximum value in the data set. If we're finding quartiles by hand, we would first arrange the data from lowest to highest, if it's not already arranged. Then we would find the median of the set. We find the median first because once we split that data into 2 halves, it's pretty easy to then split each half into another 2 sets, thereby creating our 4 groups of data. So once we find the median, we then find the median of each of the 2 halves. And it doesn't matter if you first find the median falling below Q2 and then find the median above Q2, or vice versa. Steps 3 and 4 are somewhat interchangeable. So the median of the data values that fall below Q2 is our first quartile, and the median of data values above Q2 is our third quartile. So let's put this into practice. Here's an example. The highest temperatures ever recorded in Fahrenheit in 32 different US states are shown below. Find the quartiles for the data set by hand. The data is already arranged from smallest to largest. So this first value 100 is our minimum, and the value 134 is our maximum, or also Q4. In finding the quartiles, we're also finding something called the 5-number summary. Include the minimum and the maximum, and Q1, Q2, and Q3, and we have 5 numbers that we are going to use in section 3.4 to create one more graph called a box plot, or a box and whiskers plot. So the first thing we need to do is split the data in half. Well, I have 32 values here, so I'm going to split the data in half right here. And I see in the first half, my highest value is 114, and in the second half, my lowest value is 114. So that means that my median is 114. Then, to get Q1 and Q3, notice that I have 1/2 of my data here in green and the other half here in yellow. So it's almost as if I'm going to treat these as 2 different sets. I can take the green set now, the lower half of the data, and split it in half again. Splitting it in half, I see that I have 107 and 109 here. So to find Q1, I need the median of this set. These 2 numbers are in the middle. I have a lot of even numbered values in my groups. So I need to calculate the median of an even number of data, which means I take the 2 numbers, add them up, and divide by 2. Now you may ask, why didn't I do that for the median, for the actual true median Q2 of my data? Well, if my values are exactly the same, there's nothing to find in the middle. If I add 114 plus 114, I get 228. Divide by 2, I'm going to get 114 again. So I didn't need to do that calculation if my number is repeating itself. Here, 107 plus 109, if I add those up, divide by 2, 216 divided by 2 is going to give me 108 for my first quartile. And then for my third quartile, I can split the upper half of my data in half again. And I see that 118 is showing up between these 2 halves. So my Q3 will be 118 here. And this is how we would find quartiles by hand. Granted, the way that this is set up makes it super easy because I've already got 4 rows of data, so each row is 1/4 of my data. What if it's a little bit harder?